Hello, welcome to A-level physics and mathematics. In this section, we will see about types of vector. I believe you remember in last section, we did describe about types of physical quantity, which is scalar physical quantity as well as vector physical quantity. So scalar physical quantity means a physical quantity which has only a magnitude, and then vector quantity means physical quantity which has which has both magnitude and the direction. So I believe you remember those section, and then we did see a list of scalar physical quantity as well as a vector physical quantity. So in this session, like I said, I will see about the types of vector. Before that, could you please share and then like and subscribe this video? So like I said, in this section, we will describe about the types of vector. We have a couple of, or we have broad, or we can say types of vector, which has a list of vector, but based on the different parameter like direction as well as magnitude as well as position. Vector physical quantity can be categorized in many classified. So we can classify in the different types. So namely, we can see that there is a list of types of vector, which is maybe I can show you that. So which is a zero vector, unit vector, negative vector, as well as a co-initial vector, and then so on. So these are a list of or types of vectors. So let me know if you have any any other vector type. So I'm happy to learn from you guys. Like I said, this vector or types of vector, we can classify a vector quantity based on direction, magnitude, as well as a position. So like I said, there is a list of vector quantity over here, so that you can see or you can read by yourself, and you can refer, you can use this as a reference for you guys. So these are a list or a couple of vector that will help you to understand the types of vector. Let me know, like I said, let me know if you have any other types of vector. I'm happy to learn from you guys. So here we have, we can see a one by one later on, but today I just wanted to describe for you guys a zero vector. Okay, what does it mean, a zero vector, and then how we can explain a zero vector. So a zero vector means a vector is a vector with all its component is zero, meaning that let's say we have an x component and then y component, or x, y, z component. All of these components have a zero magnitude, is a zero vector. That is called a zero vector. So I believe you understand what does it mean, a zero vector. So zero vector, just wanted to repeat for you guys. A zero vector means a vector with its all component is a zero. Like I said, if you have an x or a Cartesian coordinate system, meaning that we have, let's say, we have x and y, z component. Let's say this is y component and this is an x component. So if the magnitude of this x and the y is zero, that vector is called a zero vector, meaning that let's say if x is vector x and then comma vector y, you can represent it look like this, and then the vector x is equal to, let's say, 0, and then vector y is equal to also 0. So this is called a zero vector. We will see in the example later on, but this is a zero vector. Or also you can, this is for a two-dimensional vector, but if you want to represent a vector in 3 dimensions, maybe you can represent look like this. So let's say this is an x coordinate, or x basically we can see an x coordinate, and then this is a z. So let the vector, if this is basically a 3-dimensional or 3D vector. So if vector x is 0 and then vector y is 0 and then vector z is equal to 0, that is called a 0 vector. That is why a vector with all component is 0, meaning that that is a 0 vector. Okay, so that is all about zero vector definition, but we can represent this zero vector. We can represent by 0 as well as 0 hearts, but it's not heart. We can use an arrow in the tops, so we can represent this zero vector, or you can denote this zero vector using arrow, and then we can represent also by using a bold letter or bold face, so which will help you understand the zero vector. So there is a key basic properties for all, basically for all vector. Like I said, we are trying to just describe a zero vector in this session. So there is a list of property for this zero vector. Okay, so the first property is additive identity. What does it mean, additive identity? Let's say if you add any vector with a zero vector, you will get a zero. You will get the vector itself. Meaning that if you add, let's say, a vector v plus a zero vector is equal to v arrow. So this is called an additive identity. So this is one of the important properties of this zero vector. So you can describe this is called zero vector. Next, like I said, the magnitude of a zero vector is always 0. Okay, the magnitude of zero vector is always 0, meaning that if you add two vectors, we will see later on an example. If you add two different vectors, let's say if you add x, y, and then the sum, the magnitude, it become maybe at some point you will get a 0. Then if the magnitude of that vector is 0, then that vector is called that vector is called a zero vector. So for zero vector, the magnitude of the zero vector is always 0. Don't forget that point. And then the direction as well. The direction of that another property of this zero vector is a direction. Basically, there is no specific direction for this zero vector. Okay. They cannot specify a zero vector to north, south, east, or west. You cannot describe a zero vector like 0 to east, 0 to west, 0 to... Anyway, there is no specific direction, or there is no defined direction to a zero vector. There is no defined, or sometimes we can say that the undefined direction. The direction of the zero vector is undefined, meaning that there is no defined direction for this zero vector. So these are the key identity, or the key properties of zero vector. I believe you understand the concept of a zero vector. Let me know if you have any question. And then, like I said, could you please share and then subscribe this video to your friend. So this is all about the zero vector. So let me show you a few examples on this zero vector. So let us see an example on this zero vector. So let's say an example. So let's say a vector A as vector A is equal to 3, 2, comma, and then vector B is equal to vector supposed to be a cat. When this is a bra and then cat, we can represent a vector basically look like this, and then B is equal to negative 3, comma, negative 2. This is both let's say vector A and then vector B is given by this. So when you add, we can maybe get let's see anyway. So what we can do is let me just So we can add both of them. What we can do is vector A plus vector B is equal to, what you need to do is vector A is 3 plus minus 3 over this is 3, and then comma 2 plus negative 2, so minus 2, so which is equal to 0 3. Basically this means 3 minus 3, as well as this is 2 minus 2, right? So we can get 2. This vector is a 0 vector, meaning that, like I said, there's no specific direction, and then the magnitude of both x and y is 0, which represents a 0 vector. So that is all about 0 vector. So in this section, like I said, we did describe the types of vector, and then as well as 0 vector. So these are all about today's section. Let me know if you have any question in this 0 vector, as well as the types of vector, or if you want to add or if you want to mention anything on this section, please feel free to put in the comment section. I'm happy to reply for you guys. So could you please, like I said, could you please help me with just share and then like, subscribe this video, and then that will help me to make another video as well for you guys. Yeah, that's all for today, and then have a good day. Thanks.